9 of Google's services have more than 1 billion users each, and so you can be assured that security is always on the minds of Google's employees. Design for security is prevalent throughout the infrastructure that Google Cloud and Google services run on. Let's talk about a few ways Google works to keep customers' data safe. The security infrastructure can be explained in progressive layers, starting from the physical security of our data centers, continuing on to how the hardware and software that underlie the infrastructure are secured, and finally, describing the technical constraints and processes in place to support operational security. We begin with the hardware infrastructure layer, which comprises 3 key security features. The first is hardware design and provenance. Both the server boards and the networking equipment in Google data centers are custom designed by Google. Google also designs custom chips, including a hardware security chip that's currently being deployed on both servers and peripherals. The next feature is a secure boot stack. Google server machines use a variety of technologies to ensure that they are booting the correct software stack, such as cryptographic signatures over the BIOS, bootloader, kernel, and base operating system image. This layer's final feature is premises security. Google designs and builds its own data centers, which incorporate multiple layers of physical security protections. Access to these data centers is limited to only a very small number of Google employees. Google additionally hosts some servers in third-party data centers, where we ensure that there are Google-controlled physical security measures on top of the security layers provided by the data center operator. Next is the service deployment layer, where the key feature is encryption of inter-service communication. Google's infrastructure provides cryptographic privacy and integrity for remote procedure call (RPC) data on the network. Google's services communicate with each other using RPC calls. The infrastructure automatically encrypts all infrastructure RPC traffic that goes between data centers. Google has started to deploy hardware cryptographic accelerators that will allow it to extend this default encryption to all infrastructure RPC traffic inside Google data centers. Then we have the user identity layer. Google's central identity service, which usually manifests to end users as the Google login page, goes beyond asking for a simple username and password. The service also intelligently challenges users for additional information based on risk factors such as whether they have logged in from the same device or a similar location in the past. Users can also employ secondary factors when signing in, including devices based on the Universal Second Factor (U2F) open standard. On the storage services layer, we find the encryption at rest security feature. Most applications at Google access physical storage, in other words file storage, indirectly via storage services, and encryption using centrally managed keys is applied at the layer of these storage services. Google also enables hardware encryption support in hard drives and SSDs. The next layer up is the Internet communication layer, and this comprises 2 security features. Google services that are being made available on the Internet register themselves with an infrastructure service called the Google Front End, which ensures that all TLS connections are ended using a public-private key pair and an X.509 certificate from a certified authority, CA, as well as following best practices such as supporting perfect forward secrecy. The GFE additionally applies protections against denial of service attacks. Also provided is denial of service (DOS) protection. The sheer scale of its infrastructure enables Google to simply absorb many DOS attacks. Google also has multi-tier, multi-layer DOS protections that further reduce the risk of any DOS impact on a service running behind a GFE. The final layer is Google's operational security layer, which provides 4 key features. First is intrusion detection. Rules and machine intelligence give Google's operational security teams warnings of possible incidents. Google conducts red team exercises to measure and improve the effectiveness of its detection and response mechanisms. Next is reducing insider risk. Google aggressively limits and actively monitors the activities of employees who have been granted administrative access to the infrastructure. Then there's employee U2F use. To guard against phishing attacks against Google employees, employee accounts require use of U2F compatible security keys. Finally, there are stringent software development practices. Google employs central source control and requires two-party review of new code. Google also provides its developers with libraries that prevent them from introducing certain classes of security bugs. Additionally, Google runs a vulnerability rewards program where we pay anyone who's able to discover and inform us of bugs in our infrastructure or applications. You can learn more about Google's technical infrastructure security at cloud.google.com/security/security-design. Some organizations are afraid to bring their workloads to the cloud because they're afraid they'll get locked into a particular vendor. However, if, for whatever reason, a customer decides that Google is no longer the best provider for their needs, we provide them with the ability to run their applications elsewhere. Google publishes key elements of technology using open source licenses to create ecosystems that provide customers with options other than Google. For example, TensorFlow, an open source software library for machine learning developed inside Google, is at the heart of a strong open source ecosystem. Google provides interoperability at multiple layers of the stack. Kubernetes and Google Kubernetes Engine give customers the ability to mix and match microservices running across different clouds, while Google Cloud Observability lets customers monitor workloads across multiple cloud providers. To round off this section of the course, let's take a brief look at Google Cloud's pricing structure. Google was the first major cloud provider to deliver per-second billing for its infrastructure as a service compute offering, Compute Engine. In addition, per-second billing is now also offered for users of Google Kubernetes Engine, our container infrastructure as a service, Dataproc, which is the equivalent of the big data system Hadoop but operating as a service, and App Engine Flexible Environment VMs, a platform as a service. Compute Engine offers automatically applied sustained use discounts, which are automatic discounts that you get for running a virtual machine instance for a significant portion of the billing month. Specifically, when you run an instance for more than 25% of a month, Compute Engine automatically gives you a discount for every incremental minute you use for that instance. Custom virtual machine types allow Compute Engine virtual machines to be fine-tuned with optimal amounts of vCPU and memory for their applications so that you can tailor your pricing for your workloads. Our online pricing calculator can help estimate your costs. Visit cloud.google.com/products/calculator to try it out. Now, you're probably thinking, how can I make sure I don't accidentally run up a big Google Cloud bill? You can define budgets at the billing account level or at the project level. A budget can be a fixed limit, or it can be tied to another metric. For example, a percentage of the previous month's spend. To be notified when costs approach your budget limit, you can create an alert. For example, with a budget limit of $20,000 and an alert set at 90%, you'll receive a notification alert when your expenses reach $18,000. Alerts are generally set at 50%, 90%, and 100%, but can also be customized. Reports is a visual tool in the Google Cloud Console that allows you to monitor expenditure based on a project or services. Finally, Google Cloud also implements quotas, which are designed to prevent the overconsumption of resources because of an error or a malicious attack, protecting both account owners and the Google Cloud community as a whole. There are two types of quotas, rate quotas and allocation quotas. Both are applied at the project level. Rate quotas reset after a specific time. For example, by default, the GKE service implements a quota of 3,000 calls to its API from each Google Cloud project every 100 seconds. After that 100 seconds, the limit is reset. Allocation quotas govern the number of resources you can have in your projects. For example, by default, each Google Cloud project has a quota, allowing it no more than 15 virtual private cloud networks. Although projects all start with the same quotas, you can change some of them by requesting an increase from Google Cloud support.